So I share screen now. Okay, last time we discussed the uh, classification evaluation. We can use the confusion matrix to obtain four values: true positive, false positive, true negative, and false negative. The first one created true or false. Is for the matching or not. If the predicted value match with the actual value, then it will be true. Otherwise, it will be false. The second criteria is for the predicted value. Output is positive or negative. If it's 1, then it will be positive. 0 will be negative. Yeah. Now, based on the computer matrix, we can derive several matrices. The precision. Precision will be the column for the predicted Y. Yeah, true positive divided by the true positive plus false positive. This is a precision. The sensitivity will be the row of actual class is 1. The true positive divided by true positive plus false negative. This is sensitivity. The specificity is for the column of predicted 0 and predicted class 0. The true negative is divided by true negative plus false negative. Sorry, this is the specificity. Okay, true positive divided by false positive plus true negative will be the row, the actual class is 0. Sorry. Yeah, so the sensitivity for the row actual class is 1. The specificity will be opposite for the actual class is 0. Yeah, so they are complementary to each other. The F1 will be the average for the precision of the first one row and the first column sensitivity, and it's one average of the first row and the first column. The error rate will be the inverse diagonal duration by all the cases. The accuracy will be diagonal duration, TP plus TN divided by all the cases. Yeah. Actually, we can use the classification summary. This is for the output estimation with percentage. For this case, will be two classes, 0 and 1. So we can use this classification summary to obtain confusion matrix. Then we can calculate the error rate, accuracy, or F1, sensitivity, specificity, and also precision. Derive the confusion matrix. We need to choose the cutoff value. The default cutoff value is 0.5. Usually it's the best option. We can also choose other cutoff value to realize different confusion matrix. So we discussed the example for the output probability of the classification. We can use the cutoff value 0.5. Then we can derive the confusion matrix and accuracy and error rate.
Hey,
Okay,
I'm sorry, Dr.
Yes,
Wayne. Yeah, can you,
yes.
this is Aquarius. Can you go back to the slide that you, I think it's 22?
22. Okay. Yes.
The one that you just showed the example, was that 22?
Yeah. This is one example. Choose different color value. This color value 0.25. And from here, okay, we need to divide two parts. So there are two examples. Second is 0.75 color value.
I'm sorry, you had a slide that maybe it was further up. Go back. Yeah, that one right there. 21, yes. So I have a question. It says calculate the confusion matrix for different cutoffs according to the cutoff table below. And at the bottom,
0.5.
yeah, can you explain that? If the cutoff is 0.5 and if the cutoff is 0.75?
Yeah. The color value 0.5 will be here between 0.506 and 0.471. So we can put this cutoff value, cutoff line between these two values. So then we can derive the four values, true positive, true negative, and false positive, and false negative, false positive. Yeah, just for this example, color value is 0.5.
So if 11 of those are correctly classified, essentially we have to account for the record 0.506, the ones before that, but actual class must equals 1, which is where we got the number 11. Is that right?
Yeah, true positive, that means the predict, okay, true positive, that means the prediction, okay, the predict value is positive. Its predict value is 1. The P is positive, that means the predict value is 1. True, that means predict value is the same as is the actual value. That means the actual also 1, predict also 1.
Okay.
Predict is 1, the actual value is 1. The predict value is 1, that means all the cases beyond 0.5 are predict 1. That would be all these cases, and this one. And before 0.5, all these cases will be predicted to be 1.
Right.
The actual class 0 or 1 will be here. You can see the 1, 1, 1. This is actual 0. But the predict is 1. In this case, the predicate is 1, but actual is 0. Okay, after the out of the line of the 0.5 here, for this case, 0, the active value, active class is 0, the predicate also 0. Yeah, this is saying this active is 0, predicate is 0. But this one, the active is 1, but predicate is 0. Because all the cases below this line will be predicted to be 0. Okay, beyond this line, all the cases will be predicted to be 1. So this is the meaning of the cutoff value. So based on the cases, we can count the number 1, the number of the active 1 beyond the cutoff line. You can say one number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
11, got it. Okay.
Meaning 11 cases are active 1, but they are predicted to be also 1. Yeah, so be true positive 11. But for the cases, the active 0 beyond this line will be active is 0, but predicted to be 1. Okay, for these two cases.
Right.
Yeah, active is 0, but predicted to be 1. So they are the output is positive. The predicate is 1. Predicate is positive. Yeah, but in the actual value not matched with the predicted value. So they are false. Yeah, false positive. There are two cases.
Got it. I understand that.
Yeah, yeah, that's the meaning. So it will be similar below this line. Okay, all the cases are predicted to be 0. Okay, for the cases, the actual class are 0, like this, 0, 0, 0, 0, 0. But only the case here, the actual class 1, but predicted to be 0. Yeah.
Oh, I
So,
got it. Okay. The false
yeah,
negative.
the true negative, that means the predicted value is 0. Okay, the true, that means the predicted value is the same as the active value. Yeah, so that means for these cases will be predicted 0, the active value also 0. And predicted 0, all the cases are up here below this line are predicted to be 0. But the actual value are 0 will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, will be true negative will be 10.
Right. Got it. And then I
Yeah,
understand the false negative, the 1, which would be
yeah,
the
false
one.
negative. Yeah, it will be the predicted is 0, but they are the actual not match with the predicted value. So
Okay.
that means the predicted is 0, the actual is 1. Yeah, will be this meaning. Yeah, predicted is 0, actual 1 will be only this case. So the number is 1.
Thank you. I understand.
Yeah. Is there any questions? Yeah. Okay, we continue. So actually we have two cases here. So now we continue the next part, lift chart. The lift chart actually to evaluate the performance of the classification prediction. Actually, from the previous example, we use the probability for the classification from 0 to 1 value. We can use the cut value to determine the confusion matrix. Actually, so we can use the we use the estimation of one class. And we can use the probability of the success to evaluate the importance for the cases, whether it belong to one class or not. So we can use this policy to evaluate the possibility to be test fraud and credit default, and and also the response to the offer, promotion offer, and other cases. Yeah, so we can use this strategy to tolerate big error, and we can take the cases with high possibility to contribute the class 1. Yeah, so we can change the strategy to realize the highest profit and the benefits. Here we use the a matrix to evaluate whether one class C1 is important class. Yeah, based on the equation of the sensitivity, specificity, we know that sensitivity is to evaluate the ATO class 1, whether is correctly classified. Yeah, this will be the first row in the confusion matrix here. It will be TP divided by TP plus FA with sensitivity. We also use the specificity to evaluate the ATO class 0. Will be Tn divided by Fn plus Tn. So this is for the this specificity to evaluate percentage of the class C0 correctly classified. Yeah. We can define the false positive rate. Is the percentage of the predicted of C1 that were not C1s. So this will be the complementary to the sensitivity. So the equation like this, FP divided by FP plus TP. And the other one, false negative rate, is the percentage of repeated C0 that were not actually C0. So this is equivalent to the Fn divided by Fn plus Tn. So be the second row or second column. The column, the predicted 0. The false positive rate will be the predicted class 1, the first one column. This slide for the ROC curve. The ROC is for the abbreviation of the receiver operating characteristic curve. The meaning of the receiver operating characteristic curve is that we have this chart, yeah, to describe the relationship between two values. One is the false positive rate and the true positive rate. Yeah, according to the calculated results, we have this plot. And the diagonal, the dashed line, is for the normal distribution. Yeah, everyone case has the same possibility. Yeah, everyone has a 50% possibility. Yeah, maybe or maybe not. But actually, it's not a normal distribution. We will have the curve like the orange color plot. Yeah, this plot is not obvious. Actually, we use the cases to send out. You know, the total cases we applied, and the vertical direction will be the cases that are important, that are successful. So there we have the accumulation to see the curve. And this is based on the matrix, true positive and false positive rate. And the ROC curve actually is used in a radar signal detection. Then we can use the lift chart to measure how much does the model improve the random chances in finding the class of interest. And we can use this lift chart to evaluate how well one model identifies the most important class. Yeah, so that we can identify the potential fraud cases, yeah, in the application. Usually you can receive the email from the bank. If you have the suspicious action in the account, and the bank will send you email about the warning. Based on the lift chart, we can derive the discharge chart, and we can compare these two charts to determine which one is better for the usage. Actually, they are similar because they use the same data, but they have different curve. Both can help us to identify the important classes. And to obtain the lift chart, we need to apply many color values. One color value will be one point on the curve. Yeah, actually, we apply the color value from 0 to 1. Then we can obtain different values on the vertical duration. Then we can make this plot. So this plot will be calculated one by one using different color value. Yeah, one color value have one confusion matrix, have one specificity or false positive rate or true positive rate. So this curve actually plotted using different color value. To obtain a lift chart and a discharge chart, we need to sort the records using the predicted probability of belonging to the important class 1. Yeah, it will be the example case we discussed in the computer matrix. Yeah, just make a sorting of the probability to be 1. The high value will be more important for the case, and because they have higher possibility to be classed to be 1. So we can make a sorting of the cases. We'll realize this one table. Then we can move down the list. Noting the active class. Yeah, we have 2 columns. One is active class, the other one column is for the probability to be class 1. Then we can compare the number of active 1 to the number of 1 you expect with a known model. And so it's a confusion with no model. Just compare the number active ones and the estimated one, yeah, repeated one. So this case will be the true positive, yeah, true positive value. And just now we discussed this already. If the IQ is 1 and IQ is 0, but the repeat value is 1, so it will be false positive. Yeah. Then we use the results to obtain the confusion matrix. Then we can obtain the matrix of the false positive rate and false negative rate. Then we can derive the lift chart. And further, we can calculate the discharge chart. The lift chart will be the step function to straight line, just like the curve, the step function like this, correspond to the diagonal line. The discharge chart will be the value curve approach to be 1. Yeah, we'll show later for the discharge chart. Okay, here's the example for the lift chart. It's the same as before in the example. We have the observation cases. There are 24 observations, 24 cases, and we already have sorting for the cases according to the classification of 1. Yeah. From 0.0, 0.99, 0.98 until to be 0, almost 0. And this column for the IQ class can be 0 or 1. Okay, then we can obtain the last line column, accumulation of the IQ class 1. Yeah, here is 1, first one, just 1, only IQ 1. Okay, then this one case, it will be the value previous one accumulated class plus the current case, the class number. So will be 2. Here, this one will be previous one IQ community IQ class plus the new class is 1, so will be 3. Yeah, will be the same. So we can see the community IQ class will be increased until 7. In the case 8, the IQ class 0, but the accumulated value will be the same as the previous one accumulated value, because the new case IQ class 0 has no contribution to the accumulated value. Okay, next is 1 for the IQ class, then it will increase to be 8. Yeah, but for the case 12, also the IQ is 0, so has no contribution. The accumulation will be the same as previous one 10. Yeah, we can do this to realize last line column. Then we can make a plot on the right side. The horizontal direction will be all the cases, case number from 1 to 25, was it 1 to 24? Okay, the vertical duration will be the last one column. And we can see the curve is one step function. Initially it will be increased linearly, but at the case 7 has one step. The horizontal direction it will be the same. Then start increase. And we can have this curve, blue color. Yeah. If we so this okay, this curve is not correct. I don't know why it's draw this. Okay, the total number of the ATU classes 1 will be 12. Yeah, if they are normal distribution, will be like this dash color, dash black color line. Yeah, so the code of realization of the lift chart will be first read CSV file. Okay, then we call the function sort values on the probability column, and it's when descending direction, not from is not ascending, the descending from high to low value for the probability. Then we can call the Gantt chart function using the ATU value. Yeah. So the sorting the value, we realize this one table, and we use the ATU value will be the ATU class column to obtain community class column. So then we can make this plot. Yeah. So this is the method to realize the lift chart according to the probability distribution. And from the plot, we can explain the meaning of the point in the curve. Yeah, for the case, the horizontal direction, the record number is 10. Will be here. Record number is 10 here. And we have the cumulative gain is 9. Yeah, is 9 here. Yeah. The method we make the sorting is very important to obtain the lift chart to realize this one curve. This curve have sharp increase, have a higher slope value will be better results because we can obtain high seed benefits, high results at the beginning. If we don't make the sorting, the curve will be very it will be after odd. Yeah. The accumulation results will be slowly increase, finally reach this, maybe below this diagonal line. Yeah. The sorting can realize this way strategy, better performance. Yeah, in the application, we try to apply the cases at the beginning, so can realize the benefits with small input and small number records. We can realize the highest benefits. Okay, this is a DSLR chart. Just now I say the it will reach one horizontal line, one. Actually, there's one line here. So I draw one line here for the convenience. Here, you will reach approach this one 1.0. So I have the change for the property of this line. So I use a dash line here for the convenience. We start. So the leaf chart just show the curve approaching to the one. And this one perform not good. You can see the vibrate is not smooth. And it's not make the because this one K40 is better performance than the 30. So we usually will sort, make sure this 40 is before the 30 one, so that we can create the important classes at the beginning, and the less important classes will be later. Yeah, so they can finally approach to be one. So this one, this chart is most probably is twice as likely to identify important class compared to just picking at random. Yeah, so the leaf chart output will show the curve from most likely to the less likely members for the important class. And because we sort the importance probability before the plot of the leaf chart. So the leaf chart is one plot between the accumulated important class, that is the y-axis, compared to the total records, yeah, and that is the x-axis. Yeah, so be the case here. The accumulated class in the vertical direction, horizontal will be all the cases, include 0 or 1. Oh, sorry. Yeah, the leaf chart and the DSLR chart comparison will be in this one slide. Both embody the concepts of moving down through the records, starting with the most important of the most probably of the important class 1 to the less likely. until 0. Decile chart does this in a decile chunk of the data. We need to make the bins for all the cases. Yeah, we make categories. It's similar like the make a categorical conversion. Yeah, to divide the cases into a certain number of chunks. The y-axis of the decile chart means the ratio of decile mean to the overall mean. Now we will show this in an example later. Actually, the decile chart can be calculated based on the lift chart. The lift chart shows the continuous cumulative results. Yeah, lift chart can be continuous value. The horizontal direction, the axis from 0 to 1 for the possibility. And every one point, there can be infinite number of the points. But this chart does not have this. It has only certain number of the chunks. Here is the method to obtain the gift chart and the decile chart. Firstly, we randomly select the data into samples, 70% for the training, 30% for the validation. And yeah, we use the training sample for the training of the model using the fit function. Then we can obtain the model, trained model with the questions. Then we can use this model for the validation sample. Yeah, so that we can score the validation sample using the response model under consideration. Yeah, so we can apply this model on the training model, so we can obtain a configuration matrix using the different cutoff value. Then we can rank the scored file in ascending order by estimated probability. Then split the ranked file into 10 deciles. Yeah, so we make a sorting from high to low. Then, then group the data into 10 deciles. Yeah, according to the cases. So that we have the number of the observations in one decile. Yeah, there are totally 10 deciles. Yeah, so the number one decile has one certain number of responses. Usually they are equivalent, will be the same size for every one decile. Then we can calculate the cumulative responses in each one decile. That equivalent to the number of the responses plus the cumulative responses of the previous one case, previous one decile. The first one decile is 0. The cumulative response will be 0. Then we can calculate the percentage of the cumulative response overall the sample responses. to be presented community responses. Then we can calculate the lift value by dividing the community responses. Okay, divided by the desired value, I. And actually, everyone desired I will be the same. So this actually would be one normalization. The desired value will be, okay, sorry. Oh, sorry. Desired I, sorry, I can capital to look at. Desired I is I times 10. And one desired is the same. So the desired I will be I times the 10. This one desired size 10 value. So here we have the example for the creation of the lift chart and the desired chart. We have the the input. Okay, we have the number of deciles. We have totally 10 deciles. One decile has 10 records, and totally 100 cases. And first the row is 0. Second row will be first one decile. Decile 1 has 10 records, 10 samples, and it has 2,500 cases. Oh, sorry, here the case is 2,500, and every decile has the same size, 2,500. And the responses for each one decile are different. The first one is 2,179, second 1,753, and you can see they are sorted from high to low value. Usually the sorting actually based on the probability. They are sorted from high to low. For the decile, they have higher probability to have the response. So this is the probability will be 2179 divided by 2500. So that is why it has this one tendency from high to low value. Then we can calculate the other columns. And we can explain in this one slide. So let's see. Already have this. Okay, so we can calculate the everyone columns using the equation we introduced in the desired lift analysis method. Okay, for the community response for the column, that will be accumulated results using the previous one community value plus the current response. So we can obtain this increase until reach the maximum for a 74. So for the desired time, it will be the same as the community value is the same as the number of response because the previous community response 0 and 2179. 2179 plus 0 will be 2179. And this number will be previous one community value 2179 plus the current number response 1753 will be the community response of the current one 3932. Okay, next one the new response 396 plus the previous one community response 3932 will be 4328, etc. Be the same. Then we can carry next one column, percent of the community response. We can divide the community response to the total number, 4874. Yeah, so the total in will be the highest value in the community response column. So we can obtain the percentage value. Yeah. The DSR10 has the percentage 44.71%. And you can see the percentage of the community response will increase until 100. Okay, then we calculate the next one column lift value. Lift value will be the percentage of the community response divided by the decile value. Yeah. Decile I will be the first one column. Yeah, so the 44.71 divided by 10 will be 4.47. Okay, here the 80.67 divided by 20 will be 4.03. Okay, next value 88.8 divided by 30, get 2.96. Then we can see the value from high to low value. The low value will be 1. Okay. The random lift value will be last one column. The random lift will be default 1. Yeah, so that's why I make the plot here as 1, as one random lift value. Okay, the results will be on this slide for the lift chart and the descent chart. The lift chart, the horizontal direction will be the percentage of the data sets. The horizontal direction will be the percentage of the community response. So we have the green color curve. Yeah, so we can get the best performance at the beginning. And the other cases do not contribute much. Yeah, so just waste of money. If we want to save money in the investment, we use the initial number of the cases. And we will ignore the others because we can use a small amount of money to realize the best performance. The right side, this is the desire chart. You can see it has the value from high to low. The lowest value is 1, approach to the 1 value. The 1 is the random case, random lift value. Yeah. For the left lift chart, the better model has large area. That means it increase very quickly. If really quickly and reach the saturation in a short time, then the area will be large. So the better model has a large area between the green color and the blue color. Okay, right side this chart. If the model is better, the slope will very sharp and decrease very quickly. So the better model has smaller area between the green color and the blue color. Yeah. So actually to evaluate one model good or bad is based on the slope. Yeah, slope drop data quickly or increase very quickly on the lift chart or the DSR chart will drop very quickly. So the better model will realize the higher slope value. So we can realize this lift chart and DSR chart using this procedure. First, we make the classification, training, then apply the classification on the validation data. Then we use the probability of the output to make a sorting. Then we can obtain the lift chart and the DSR chart. Yeah. Actually, we already have the code. Yeah. And just we have here. We make sorting first. Yeah. Yeah. Actually, before this, we need to make the training and then make prediction on the validation data. Then make the sorting on the probability. Then we obtain the Gantt chart. A Gantt chart will be the lift chart. Okay. Further, we can have the DSR chart. Okay, we have this. So from the previous discussion, we can know that the Gantt chart and the ROC curve have similar appearance. And they both increase very quickly at the initial stage and reach the saturation very quickly. Yeah, so they both have similar appearance. Yeah, in the ROC curve, and also the AOC curve, AOC value, the area under the curve, both provide the possibility to assess model ability to identify the classes. Yeah. The lift chart just use the different cut value and obtain the obtain the lift value. Yeah. So actually, this method is actually to apply the cut value. Yeah, here the cut value is 10, then cut value is 20. Yeah, until 100. So we have the cut value, then we can obtain different points in the lift chart, lift chart or the DSR chart. And this actually is not a measurement based on the overall performance, overall metric, because they process based on individual bins, individual cutoff value. Yeah, the tendency or performance, good or bad, based on the calculated results. Yeah, I only obtain this curve, then we know whether it's good or bad. We can see the slope increase very quickly or not. Well, here are questions. What is to accumulate the correctly classified important class records, y-axis, and compared to number of total records, x-axis? Yeah, can you answer these questions?
So is that, let's see, I'm looking here. Is that a function of looking at the records to the cumulative gain? That's based on the chart you just showed, right?
Yes, yes, based on the sort chart.
Okay, the green one, hold on. Let's see.
So this should be the Gantt chart or lift chart. And Gantt chart to accumulate the, or lift chart to accumulate the important classes. Yeah, so this would
So,
be the, you can see from here,
mhm.
this is the accumulation results here. So we can use these accumulated results to obtain the lift value. We accumulate response here. So we can obtain accumulated responses. Yeah.
I'm sorry, I have a question. I thought in the question it was asking about the analysis and the data that's in the lift chart and the decile chart on page 41, right?
Yeah. Yeah, these are chart.
So essentially, in order to answer the question, we want to look at, because what you have noted here, it says the better model has a larger area.
Yeah, so it's
Right.
firstly we need to calculate accumulation value.
Mm-hmm.
Compare is the one division to the total number of records. So this actually to describe this percentage. This will be this one. Percentage.
Norm of cumulative response. Okay.
Yeah, will be here. Will be community response divided by total responses. Yeah, will be this one equation.
Okay.
Yeah. Yeah, is it correct or not? Yeah, it will be the definition of the concept for the percentage of the accumulated responses. Yeah, will be the percentage accumulated responses. Yeah, here this one, second equation. Yeah. Okay, we continue. Do you have any questions? Yeah, do you have questions for the code? Have you successfully finished the assignments for the lab?
Wait, you talking about assignments prior to now, or the one that
Yeah, the lab 1, lab 2, do you have any difficulties?
No, I mean, me personally, I've posted those. Some of them though, I don't think you've graded them, so you still have to grade
Oh,
some, correct?
okay. Yeah, graded already several. Maybe new submission have not graded. I will grade later. Yeah. Or maybe you submit recently. I didn't grade.
Yeah,
Check.
just speaking for me personally, there's some that I previously submitted that weren't that haven't been graded as of yet.
Recording
in
progress.
Yeah, you submit 25. Oh, different. Sorry.
And
Yeah, I see you submitted March 3.
Mhm.
March you submit. I grade as soon as possible. Yeah, I didn't have enough time to grade them.
Okay.
Later. Okay. Okay, we continue. Asymmetric cost. Actually, asymmetric cost will be one strategy applied to the classification when based on the lift chart and desire chart. The lift chart list of desire chart already have the strategy sorting the probability, so we can put the important cases at the beginning, so that we can realize the a better performance of the lift chart. And we can further to apply other strategies to realize the improved lift chart and Gantt chart. Yeah, so this will be the asymmetry cost. Yeah, the previous discussion for the cases, everyone case has the same cost with the same money for everyone case. Here we may have different strategy. A different case has a different cost. Yeah, just like we want to emphasize the interest if the feedback is can get more benefits. You can emphasize the benefits with more income. Yeah, if you emphasize the waste of money, you can apply the higher weight for the loss. Yeah, so we can discuss this further for the lift chart and Gantt chart. So the misclassification cost may differ on the different situation. Yeah, we have the false, positive, false, negative. The false would be the non-match between the prediction and the actual value. So the misclassification error may be higher for one class than others. So that's why we will apply the asymmetry cost. Yeah, we apply different weight for the different class. So we can emphasize the benefit of making one correct classification with higher benefits than the other. Yeah. Other classes. Yeah, so that means we actually this class can be said is just different beans. Yeah. So the initial beans has higher benefits. Okay, the later beans, yeah, have less amount of benefits. Yeah, and also if you make credit classification for one, we have a high benefit. If you make credit classification 0, because have no value, have no contribution, so its benefits will be less. This is what I mean. 0 or 1, yeah, quite different meanings, different contributions. Here we have the one example. We have one case to send the offer to 1,000 people. The only 1% average response rate. That means 1,000 people, only 10 people will send back the feedback. Yeah. So here we define 1 for the response, 0 non-response. So the 1 class has more benefits, and 0 part just waste of money, has no benefits. And it will be negative benefits, no contribution. The naive rule will be the strategy to treat every class the same. Yeah, everyone class has the same possibility. Yeah, it will classify everyone to be 0. And that means nobody will have response and no response. So the 1% will be error rate. Yeah, for the naive rule. Now this table shows the ATU 1. Yeah, we send out 1,000. Yeah, 1,001, but only has 10 response. And the class ATU 0 will be 990. This 990 has no response. And we can use the data mining method and make the training. And we can make the classification for individual case. And we can make a CRED classification with 8-1. Okay, will be here, the computer matrix. Originally, it's totally, we have the 10 response, but 990 has no response. But based on the prediction and the classification of the data mining model, for the 81 case, 8 are predicted to be 1, 2 predicted to be 0. And for the 80, 20 predicted to be 1, 970 predicted to be 0. So this will be the computer matrix derived from the data mining model. From here, we can calculate the error rate. Error rate will be this one, inverse diagonal duration, 20 plus 2, divided by all the value, will be 2.2%. The previously just the 1% for the error rate. Now we have 2.2% error rate. But the meaning is different. The error here in the naive rule is 1, but the CRED is 0. So this CRED classification has no contribution. Here we have the 2.2 with the data mining. Very weak error rate, but a very high accuracy. This accuracy is very benefit, but naive benefits is very weak. Just lose money. Here we should apply a different strategy using a cost and benefits concepts. And continue with the previous example, we define a profit for one response to be $10 for every one response, one. The cost for sending out one offer is $1. Now, so that we can derive a new confusion matrix. This confusion matrix will be the profit matrix. And because this profit matrix using the profit and the cost concepts based on the confusion matrix. So yeah, under the naive rule, yeah, all the classes are predicted to be 0. Yeah, actually, no offer sent, no cost, no profit. Yeah, under the dead money prediction, we created the confusion matrix.
Dr. Wang, I have a question.
Yes.
So if I look at the answer that provides the net profit of 60, I understand the prediction of 1 and the actual of 1 because that's 8 times 10, right? So profit from a response of 1 is $10.
Yes, yes.
But what I don't understand is why actual of 0 and predict as 1, why that's a negative 20.
Okay. Okay, for this one, because it has the cost sent out offer.
Oh, so essentially, when you're looking at it,
because
profit,
this,
that's positive, but a cost would be negative. So the cost to send,
is
even though
negative,
it's a
yeah.
dollar, it costs the company $1, which is why it's negative 1 times 20.
Yes, yes. Yeah,
Okay, got it. Okay,
right. Cost is negative value.
got it. Thank you.
Yeah, welcome. Yeah. So the classified, I mean, this is prediction. Yeah. All cases predicted to be 0. That means no offer sent out. There's no for the prediction, there's no loss, no cost. And without the send out, we don't have the response, so no profit for the naive rule. So this is for the prediction. So all this is based on the prediction. And based on prediction, you will apply the activity, send out offer or not. Yeah, just predict to be 1, we'll send out the offer. If we predict 0, we will not send out the offer. So we will, for this case, we don't send out offer, then we actually have the loss. For this case, actually they will respond, but we didn't send out offer. So actually it's why potential cost but this is not real cost. Because we didn't send out the offer, so we don't have the cost here for these two. And for this 8, we predict to be 1. That means we send out for these 8 people, and they have the response, so they will have the profit 10. So 8 times 10 will be 80. So this 8 case will be the benefit or profit. Okay, for the 20, the predict to be 1, we will send out the offer to the 20 people, but they didn't have response. So this will be the cost. One person will be $1 cost, will be $20 cost, because cost is negative value. And for the this column, the predict to be 0, because this predict 0 will not send out offer to them, so there's no cost. Yeah, because we didn't send out, and so didn't have any receipt, so there's no profit for the 2, no profit for 2, and no cost for 970. Yeah, do you have questions for this?
Yeah, no questions.
Yeah, all this profit based on the prediction. Okay, based on prediction.
Oh, I'm sorry. I do have one question. What does DM stand for? It says under DM predictions, 28 offers are sent.
Uh,
It says under DM predictions, 28 offers are sent.
20 offer.
Yeah,
20
no.
send out.
I'm asking. It says DM. What does DM stand for?
DO, the data mining.
Data mining. Okay. Thank
data
you.
mining will be model, yeah. Data mining model.
Got it. Thank you.
Yeah. Yeah, so the predict at 1, meaning sending offer. Yeah, predict 0 will not send out offer. Okay, this will not send offer. And predict 1 will send offer. The 81 it will have response. Yeah, and 0 has no response, will not send out feedback. Yeah, so we have this profit matrix. Any question to this one slide? Yeah, it's very confusing if you may create understanding for individual concepts. Yeah, so it's different with the computer matrix. We apply the profit and cost to the prediction results. Then we can have this profit matrix. So the profit based on the prediction. Yeah. We send out the offer. In response, there's profit, and no response will be will be cost. Yeah. Right. So that's the application of the confusion matrix. Yeah, confusion is based on the color value. Yeah. So actually, this will be 1 point in the lift chart and the desired chart. Okay, here we have question. Now suppose we send an offer to 1,000 people with 1% average response rate. 1 is the response, 0 is non-response. If naive rule classifies everyone as 0, then what is the error rate?
1 is response and 0 non-response.
Yeah.
If everybody's classified as a 0,
Mm.
let's see.
Naive is one prediction. Predict everyone case to be 0. What's the error rate?
Wouldn't it be 0 if everybody's classified as a 0?
Yeah, naive rule, we treat everyone case is 0 for the that means nobody responds. Nobody responds. So the error will be this error every response. That means 1,000 people will have 10 people response. So 10 response will be the error. Yeah, actually will be 0 response based on the naive rule. So the error rate will be the 10 by 1,000. So the error rate is 1%. Yeah. So you can go back to check here. It is already mentioned here. The error rate is 1%. They treat everyone case predict to be 0. It predict everyone case had no response. Okay. So any questions? Yeah, we'll continue. And next one question, suppose we send one offer to 1,000 persons. The confusion matrix will be provided here. And suppose that the profit from one is $10, the cost sending offer $1. What is the profit matrix from this? Yeah. Can you practice this? Yeah.
Yeah, wait a minute. So the profit from a 1 is 10. Okay. Let me see. 700. And then 700.
The cost for one offer is
Is that is the profit 675? Wait a minute, 700. 10.
675.
Is that 675?
675. Why 675? Can you share your screen?
Oh, I did it in my head, but so if the profit is $10 from a 1, that should be 70 times 10.
Yeah.
which will be 700,
Yeah, 700. Yeah, right.
right? And then
So
the
this
cost
will be
for
700.
sending an offer, it costs the company $1.
Yeah,
So that would be negative 25. So, and then everything in the zero column will be zero.
yeah,
So
zero.
700 minus 25 is 675.
Yeah, so below this. Yeah.
Yeah, so that's why I got 675.
Oh, 725. Okay, six, yeah, 675.
675,
Okay.
yeah.
Yeah,
Right.
you're right. You're right.
Mm-hmm.
Yeah, so we, mm, yeah, so insert, will be 700 minus 25, 675. Yeah, right. Yeah, so this profit matrix will be this. Okay, next one, topic is a lift. We can obtain updated lift chart based on the previous analysis. We can add the cost and the profit to the computer matrix and the matrix. Yeah, applying the cost and the profit will not change the results of the classification. Yeah, so here is to discuss the generalization of the cost ratio. Actually, we have difficulty to estimate the actual cost and the benefits. So it's better to express everything in one term, just the cost. Yeah. The cost is the misclassification for record. So the goal is to minimize the every year cost for record. So we can replace the individual cost with a ratio of the misclassification cost. So here we have the example. The misclassifying fraudulent form is 5 times more worse than a misclassifying sober form. Yeah, so we can express the cost with the misclassifying cost. So here we have the equation minimizing the cost ratio Q1 over Q0. And so it will be cost ratio of the two classes. So this is identical to minimizing the average cost per record. Q1 is the cost of misclassifying AT1. Q0 is the cost of misclassifying AT0. Yeah. Yeah, any questions for this? Here we discuss the opportunity cost. And we can convert everything to cost. Yeah, just misclassifying cost for one class. It's better than misusage of the cost and profit, cost and benefit. Yeah, so we will not use the benefit from sale. We will use the opportunity cost of lost sale. So we can derive a new matrix based on the opportunity cost. So this will be more applicable in a case, in a situation. So based on the configured matrix we obtained from the data mining model, in the previous discussion for the profit and cost, profit matrix, we have profit for response Y with $10. The cost sent out offer is $1. So here we have the cost matrix. Here we have the opportunity cost, $10 for one record. Printed at one column, we send out the offer. So the cost will be the the number of cases plus $1 or plus $1 because they have response. Yeah, so the cost will be $1 for one case. The 2020 printed Y I2 0, they also have a cost 20. Yeah, one case $1. For the case, these two, pretty 0, I2 1, because we didn't send out the offer, but they are potential response. So we will treat this as one cost. This is the opportunity cost. So one opportunity cost will be $10. So there are two cases, 2 times 10 will be $20. For the case 970, pretty 0, we didn't send out offer. We don't have the cost. So cost 0. So the total cost for Q1 is misclassifying H1. Misclassifying Y, H2 class 1 will be $20. This will be Q1. Q0 Q0 is defined, misclassifying ATU0. So misclassifying to be 0 will be this one, with $20. So the ratio will be Q1 divided by Q0, $20 divided by $20 will be 1. So cost ratio for this case is 1. Hey, do you have any questions? So this is the opportunity cost for the case. We didn't send out the offer, but they will provide the response. This will be the opportunity cost. So here we have practice. Yeah, suppose we send out one offer, 1,000 people, 1,000 persons. Then the computer metric will be here. Suppose the opportunity cost per record is $10, cost send offer $1. What is the cost of the matrix? Yeah, can you try this?
Yeah, I think it $10. I think it might be $2. The cost matrix.
Yeah, 2. Yeah, cost ratio is 2. Cost matrix will be 7. This is 70. This will be
And that
5
would be
times.
5 times
10.
10, that would be 50.
Yeah,
And then 25
and is
and
also
900. And so the 50, it would be 50
5.
divided by 25.
So, and also we can calculate the cost ratio. Yeah. And cost of the matrix. So the result will be this 5 times 5 times 5 times 10. So this will be 50.
50.
This does not have cost, no computer matrix, no cost for this. And 70, 25, all is 1. So this is the cost matrix. The cost ratio will be this two. This is the Q1.
Q1 over Q0. And
So
Q1 is the 50 and Q0 is the 25.
so Q1 will be misclassified 1. Misclassified 1 will be this one 50.
Right.
With 50.
Over
Q0
25.
misclassified 0. Misclassified 0 will be 25. 25. Okay, so ratio will be 2.
2.
Yeah.
Yep.
Cost ratio 2. So that means the higher cost ratio will be worse. We try to reduce the cost ratio.
So ideally we want the cost ratio as low as possible. So the lower the better. So the other problem we did, the cost ratio was 1, so that would have a better cost ratio than this one. Correct? Is that correct?
Because so they are all costs. Yeah. Yeah, the cost is not good. We don't have a high cost, but this ratio means misclassifying. Which one? That means That depends on what which we focus on. Which one we focus on? We focus on the cost from the loss of the opportunity, or we focus on the loss of the money. And maybe we usually focus on the loss of the opportunity. So so the higher cost ratio will be worse. Yeah, the higher cost ratio means we have the higher loss of opportunity. We'll try to reduce the cost ratio.
Okay.
Yeah, I think so. Do you have any suggestion to this?
Mhm.
Yeah. Usually opportunity is more important. We try to reduce the opportunity cost, so the cost ratio will be lower.
So I'm sorry, just to repeat that, you saying, opportunity cost is more important than what the cost ratio would be? The last calculation that we just did
Yeah,
before this one?
yeah, because we don't want to lose the opportunity. The higher opportunity cost, that means the real cost is very will be vital, will be fatal to this program, because we lose a lot of opportunities.
Okay,
Yeah, we don't want to lose opportunity.
got it. Thank
If
you.
in the previous one example, the cost ratio 1, that means the misclassifying two cases, two red bonds, not red bonds, were equal. That means just an average. Yeah, if larger than 1, then we will have the problem in the in the model analysis. Yeah, for this case, we need to change the model to reduce the error here. Reduce this error. Yeah, these two are all errors in the inverse diagonal notation. This try to reduce this error. This error will be the misclassification for the prediction. So that's why it's asymmetric. Yeah, we'll apply different weight on the misclassification. Yeah, so apply the weight 10 on the top right corner, but the low left corner just 1 weight. This is asymmetric cost. Okay, do you have any questions? Okay, we'll continue the next one. We have the opportunity cost for record $20. When offer costs $2. And from the computer matrix, we can calculate Q1, Q0, and the cost ratio. Yeah, can you try this? Yeah, you can try this on what's the results.
let's see.
Yeah, have
Is
you?
the Q1, okay, so I think that first number is 200, predict as one, actual one's 200, and I think the predict as
It's 400.
0, 200, yeah. What?
Two to be 400. And they also come to 400 cost.
400.
This will be,
Isn't that 100
100.
times 20
Yeah,
or
so be
2,000?
2000. Yeah, this one no cost.
I have that 0.
Yeah,
And
but
then
we
the
cancel out. Yeah,
cost ratio, Q1 divided by Q0. So
yeah,
wouldn't that be 2,000 divided by 400?
yeah.
And
Maybe 2000.
yeah, that would be 5.
Yeah, 400. Yeah,
Mm-hmm. Be
too
5.
high. Too high.
Mm-hmm.
Yeah. So this model this model prediction is not good. Yeah, we need to change the model. So we can use this to evaluate the the models, which one model has best cost ratio. Yeah, so it's one way. But before we just use the accuracy error rate. We usually like highest accuracy to be the best model. Now, if we use the idea of opportunity cost, yeah, then we can make the asymmetric cost to make a new evaluation method. So it's more professional or more practical in a real case. Okay, this is the multiple classes. We already discussed this in a example code. Yeah, if we have M classes, then the configuration matrix will have M rows, M columns. Yeah, in the previous configuration matrix, just 2 classes, 0 and 1, we have 2 columns. If we have M classes, we have M column, M rows. And that will be totally M times M and 1 misclassification costs. Yeah. And any case will be misclassified in M and 1 ways. Yeah, just the only one is correct. The other class will be wrong. Yeah, we M minus 1 is wrong. Only one is correct. So it's too much, many calculations. Yeah, we usually interested in just one class as the primary interest. So here questions M classes, configuration matrix has M row, M column. Theoretically, what's the misclassification cost? Yeah, actually, just now we discussed it already. Will be total. The total cost is M times M because there are M row, M column, M times M. There are only M correct classification. So this will be M squared minus M. So this will be M times M minus M. Yeah, so this will be M minus 1. Okay. For the M classes, computer matrix has M row, M column. How many ways could any case be classified, misclassified? Actually, yeah, we discussed this will be M-1 misclassified. Only one is correctly classified. We can add the cost benefit to the lift chart. And we can sort the records in descending probability of the success. And for every one case, we record the cost benefit of the actual outcomes. Then calculate the cumulative cost and benefit. Then we make a plot for the lift chart. SS is the index number, YS is the cumulative cost and benefit. The reference line will be the diagonal direction. Yeah, just the dash line from the origin to the endpoint. The YN, total net benefit. Okay, so the result will be like this. And you can see the plot of the cost benefit lift chart has the negative slope. Yeah, because the cost is too high. So cause the negative value. Yeah, because the cost may be the negative value. Yeah. Benefit is a positive value. If the cost is higher than the benefit, the slope will be negative value. So the benefit is positive, but the cost is negative. Yeah. So the total net benefit may be negative. The negative will be the endpoint, so has a negative slope. Yeah, so we can choose the cut value to make sure the point has a maximum value. Yeah, at here. So we will apply the strategy. Just apply cut value here. Yeah, we will send out offer to the cases before this line, this vertical dash line, so we can realize the highest benefits. Yeah, so this is the lift chart usage. And from the lift chart, we can determine where to apply the cut value for the highest benefits. Do you have any questions? We don't have, we continue. Okay, we have a question. If total net benefit from all cases is negative, what slope will the reference line have? Yeah, you can think about this. Yeah, total
Wouldn't,
net benefit.
wouldn't it go down, if it's negative, it would go from,
Yeah,
trending downward?
yeah, so it will be here. So this is the
Mhm.
benefit. Vertical direction is the benefit. The benefit is negative, so the slope reference line is here will be negative slope. Yeah, will be here. So the vertical is benefit. For the y-axis. Okay, the horizontal. Horizontal, it will be the cases, number cases, case number. The case number. Yeah, we apply more cases, the benefit become negative value. That means we will not have benefit, we only have cost. You know, try to reach the highest benefit here. So the case number will be just 3,000. We just use 3,000 cases to realize the maximum benefit. Yeah, the more cases, the less amount of benefit we realize. We'll have more cases, we will lose money. Okay, next. So the slope will be negative for the reference line if the benefit below 0. Second, the goal of the community benefits is to use cutoff to select a point. What is the benefit, net benefit of that point? Yeah, what's the location of that point for the net benefit? So that is the maximum value
Okay.
of the net benefit at that point. Yeah. Just at this point, we have maximum value for the benefit. So this is the cutoff value for classification to be 1. Predict to be 1. So we predict to send out the offer.
Okay, and Professor Wayne, oh,
Yeah.
yeah, that's what I was about to ask, could you go back to the other one? Just
Which
so
one?
I could, the question that, right, that one. I was just, wanted to write that down.
Which one you have question?
The one we just went over, the goal of the cumulative benefit,
Oh, okay.
to use the cutoff to
this one?
select a point.
Oh. Community response. This opportunity cost. Which one slide?
Oh, no, the one that we was just on, the 2 questions that we just, the slide we were just on.
Here, this one? Oh, sorry. Here?
Yes.
Community or benefit. Yeah. The goal
Yeah,
of
what was the
benefit.
net benefit of that point? And you said that's the maximum value.
Yes, you're right. Yeah, here, the goal to use the net benefit is at the maximum.
Okay, thank you.
Yeah, welcome. We'll continue. Okay, next part is oversampling and asymmetry cost. Okay, maybe we stop here today. We almost 9:30. So we'll continue next time.
Okay, I have a question, Dr. Wayne. I
Yes.
saw on Blackboard that we have a test we're supposed to turn in between today and the 12th. Is that
Uh,
right?
Yes, I think so. Is the open, can you access the exam now?
Let me see. Hold on. Because I saw that when I was looking around.
It
Uh,
should be available already. Yeah,
let me
it's,
double
yeah, you
check.
can
Hold
access the exam now. Yeah,
on. Let's see here.
you can
It
see it.
it says you have to do it. Wait a minute. It says you have to do it in one sitting, and it's 4 hours.
160 hours.
Wait, let me.
Oh, 4 hours. Yeah,
It's 4 hours, but you have to do it in one sitting. So it sounds like you can't start it and go back to it. Is that right?
when you sit down to start exam, you have to complete within 4 hours.
Right.
Because it use the
But
camera.
what I'm saying is that once, okay, I have it here. What I'm saying is that once you start, you can't
Yeah.
like stop and go back to it. You have to keep going, right?
Yeah, because it's a monitor. The monitor,
Okay.
the camera will see you should be there. Because it's the system exam, monitored by the camera.
Okay, but you can have multiple attempts. Is that right? From what I
Give you
see?
three chances. Yeah.
Okay.
If you think three not enough, you can let me know.
Okay, no problem. All right. Thank you.
Welcome. Okay, good luck.
Thank you.
And see you next week. Bye-bye.
Okay. Bye-bye.
Goodbye. Professor, could I ask
Yeah,
you
good
one more
night.
thing?
Yeah, have a nice day. Bye-bye.
Bye.